All right, welcome to Geometry 7.1, Angles of Polygons. Before we start talking about the angles in polygons, let's first review what a polygon is. So a polygon is just a figure in a plane that's enclosed with at least three sides. And the number of sides for a polygon has to be a whole number. Know the names of polygons. So a three-sided polygon is a triangle, a four-sided polygon, quadrilateral, five-sided pentagon, and so on. So if I create a polygon like a hexagon, so here's hexagon A, B, C, D, E, and F. The sides are made up of consecutive vertices of a polygon, but a diagonal, such as CE is a diagonal, CF would be a diagonal, CA would be a diagonal. All of those are the diagonals. From point C, I can create diagonals from vertex or point D as well. So there's quite a few diagonals in there, but a diagonal is just a segment that's made up of non-consecutive vertices of the polygon. Notice I started with a hexagon, so the six-sided figure to show you the diagonals. I didn't start with the triangle because any segment in the triangle would have to be from consecutive vertices. A triangle actually would not have diagonals. So that kind of leads to the interior angle sum of any polygon. Let's take a look at that. And before that, I'm going to build a table. If I take a look at the number of sides of a polygon, the minimum number of sides we could have is 3. Should know the name of that is a triangle, regardless of what kind of triangle you have. And you should already know the sum of the interior angles of any triangle, 180 degrees. Can you figure out the sum of the interior angles of any four-sided polygon? The name would be a quadrilateral. Every four-sided figure is a quadrilateral. If you're thinking maybe square, rectangle, whatnot, those are specific types of quadrilaterals. But can you think of, or do you know the sum of the interior angles of any quadrilateral? If you're not sure, you can draw out any quadrilateral, for example, something that might be a trapezoid. And as long as you know the sum of the interior angles of a triangle is 180 degrees, you can figure out the sum of the interior angles of any polygon. Because for this quadrilateral, let me call it quadrilateral ABCD, I could draw just one of the diagonals. I actually don't want to draw them both. I don't want to draw both BD and AC, but I know the sum of the interior angles of triangle ABD is 180 degrees. The sum of the interior angles of triangle DBC is also 180 degrees. All 6 of those angles make up all 4 of the angles of the quadrilateral. If I take 180 plus 180 or 180 times 2, the sum of the interior angles of any quadrilateral is 360 degrees. A 5-sided figure is a pentagon. Can you figure out the sum of the interior angles of a pentagon? Maybe continue this to a hexagon, heptagon, octagon as well. So if you figured out the sum of the interior angles of a pentagon, a 5-sided figure, is 540, that would be correct. Let me make some lines here so you can keep track of which goes along with what. The sum of the interior angles of a hexagon. And here's a hexagon. You could break that up into 1, 2, 3, 4 triangles. The sum of the interior angles of all 4 of those triangles is 180 times 4. So that would be 720 degrees. That's the sum of the interior angles, all 6 of the interior angles of a hexagon. For a heptagon, that would be 900 degrees. For an octagon, 1,080 degrees. For an n-gon. So think about, maybe you can come up with on your own an equation or a formula that you could use to find the sum of the interior angles of any polygon. There's usually someone in class, if I give them a few minutes to figure out the sum of the interior angles of any polygon, that either comes up with the equation or some sort of variation of the equation. But here's what you can do for any polygon. Like this quadrilateral has 4 sides. I broke it up into 2 triangles. This hexagon here has 6 sides. I broke it up into 4 triangles. If I created an octagon, I could actually break it up into 6 triangles. So the number of sides of the polygon minus 2 would be the number of triangles in that polygon. And then you just multiply that by 180. You could write it like that. You can write it like this, 180 times a quantity n minus 2. Sometimes people come up with the equation or the formula, 180n minus 360. All of these are actually the same. This last one comes if you distribute the 180 to the n and the negative 2. But all of those would give you the sum of the interior angles for any polygon. Let's just say I wanted to figure out the sum of the interior angles of a 20gon. So a polygon with 20 sides. Yeah, I'm not even going to try to draw that, but you could use this equation or formula to find the sum of the interior angles of a 20gon. 20 is the number of sides, so you could take 20 minus 2, that's 18. Multiply that by 180 degrees. So 18 times 180, the sum of the interior angles of a 20gon would be 3,240 degrees.